This is problem 6 of Neetcode 150, Encode and Decode strings. So in this problem, we're given an array of strings. For example, the input can be an array containing neat, code, love, you. And we have to find a way to encode it in a single string and then decode it back to an array. So let's say that we're given the array of strings which contains sad, sweet, fantastic, and you. One way that we can encode this string is to write a single character between both. So you could simply say, all right, sad, all right, sweet, and fantastic, and you. But the problem is that in the problem, we are not guaranteed that the strings themselves won't contain one of these special characters. So fantastic here could potentially have this, for example, which will cause a problem because the way we encode the current array will make it look like we have 5 strings where we only have 4. So we have to find a better way to encode the array. And this way is basically to use a number to assign the length of the string. So for example, set as 4 characters, sweet as 5, fantastic as 9, and new as 3. And after this number, we're gonna add the special character. I like the slash here. So you can see that our encoded version will look like this: 4/sad, 5/sweet, 9/fantastic, and 3/you. And this is what we're gonna have to do for the first part of the problem. For the second part, we're gonna have to take our encoded value and bring it back to an array. So the logic in plain English is if you find a slash, take the number before the slash, and then take that number of character after the slash. So you see the slash, you take the number before, which is 4, and then take 4 characters after the slash. This is how it's going to proceed. So we're first going to start creating our string. Encoded equal perfect, an empty string, and we're gonna loop for every string within that array. So for word in S, and we're gonna append each word to be encoded. And basically we're gonna take the length of the word, and we have to make sure that this is a string, and we're gonna add our special character here. I want to add a slash plus the word itself, and then we're going to return the encoded. Okay, so that's everything we have to do for this problem. All right, once we have this, we're gonna have something like that. So exactly what we saw in the introduction. So you have our length or a special character and then the word. So now we've completed this this first section, and we're gonna have to decode it now. So first thing we can create is our decoded array, which is gonna contain the decoded string, and then we can use a while loop to go through the characters of the strings So first we're going to create our index and set it to 0 and say while the index is smaller than the length of the s, we will want to have basically two pointers, so g and I, where I is going to represent the start of the string and g is going to represent the end. So basically we're going to say while the value at sg is not equal to our slash, we're going to increment g, and once we break the loop, we're going to have the position where the first slash is, and we're going to have to take the value at the index before this. This is going to be the number that will represent the length of the string we want to retrieve from that encoded string. So the length is going to be equal to basically s starting from I up to g, and this has to be an integer. And now we want to set the start pointer I basically to the index after the slash, which is g plus 1. And we want to set g to the last index of the string. So it's going to be g, well, g is going to be equal to I plus the length. And we're going to append to our decoded dot append the string that starts after the slash and that goes up to the end of the character. All right, and after this, we want to go through the rest of the strings. So we're gonna have to set I to g, which is the last index of the decoded message. So by doing this, we're gonna loop again with our I, which is now completely after the first encoded message. And this is the entire logic for this problem. You can now freely return the decoded message and submit it. All right, and this problem has a time complexity of O of m for each encode and decode function calls. It also has a space complexity of OM plus n for each encode and decode call. All right, I hope you learned in this video, and I hope to see you in the next one.